So what are the odds you bring 2 laptops and one decides to update literally just before you go to power up? So excuse us for 2 seconds while we get the video going. I'm just floored. Anybody ever seen the movie The Story of Anvil? You got to check it out. It's about this aging rock band that used to be somebody. And they get this gig in Japan, of all places, and it's at 11 o'clock on the morning, and they're going, man, this is going to suck. And I walk in, and the place is packed out. So thank you all so much for showing up this morning. This is great. The PowerPoint gods are almost with us, so then if the VGA guys join up, we should be good to go. I'm Doug Lease. I'm a security consultant from Calgary, Alberta. It's a little place just north of Montana. You might have heard of it. All right. If you ever get the chance to go up there, I highly recommend it. If you're going to go at once, make sure you go during Stampede. We tell people it's like Mardi Gras with cowboys. The whole town gets drunk for 10 days. It's phenomenal. And if you're actually good at that whole cowboy thing, there's a lot of money in it. It's one of the most lucrative rodeos in the world. So if you can sit on a bull for 8 seconds, you could win yourself $100,000. Oh yeah. Now, I did mention you got to sit on an angry bull for 8 seconds. And in order to get to that 100,000 round, you have to do it with style about 6 times. But if you can do it, there's $100 grand in for it. So we got video, recording, good to go. Okay. Depends on the year. But yes, unfortunately, this year that would be about 80 grand American. So, and then there's the whole bull part. So maybe you just get good at computers, and maybe you don't have to learn how to ride bulls. Be safer. All right, and shout out to any Canadians that are here this morning. I see a few. Well, you're not really Canadian. He's conveniently from any country that South Africa, England, Canada. It's great.
Yeah. Okay. I'll just hang on to this. He's a lot better at this than I am. I'm still pretty new. Thanks everybody for coming out. There is an awful lot of people here for Sunday morning. If you guys can hear me in the cheap seats, just let me know. We've already done some introductions. This is Doug Lease. My name is a security consultant with TrustWave. Our disclaimers: the opinions and views expressed in this talk are not necessarily those of our respective employers. That's a pretty important topic. I don't really know how relevant this is anymore, but even though we are Canadians, we haven't driven a dog sled and we don't know Albert and Toronto. But we're all really connected through the internet and everything somehow, so there's that. Everything you're about to see today is in alpha testing at the moment, so we kind of weren't expecting a DerbyCon talk. We got the DerbyCon talk, so it really accelerated a lot of our timelines, and as a result, we had to put a lot together to get this going. So again, it is alpha testing. We have users using it, but stuff works. Everything that you see has been tested, so life's good. So what do we have here? So DNS Miner, put simply, is a DNS sinkhole built on fault-tolerant cloud-based infrastructure, and is designed to actually ensure that malicious domain requests never make it to their intended destination. We'll go through a lot of the features and everything like that a little further on, so this is just the high level. What it really does is it saves incident response time. We come from shops where we've had to be one-man armies when it came to handling our security incidents, so this really can save a lot of time. So why did we build it? It's personal. We want to know what's going on in our environment with our DNS, and we'll get into why that's really important a little later as well. But we wanted to know what was happening with all the traffic that was coming in and out of the environment. Because we could. Why do people climb Everest? Because it's there. For us, this was Everest. And the doctor said so. Paul Vixie's DEF CON 22 talk, we were sitting in there discussing that, and that started getting the wheels turning of, we need to put together a larger scale DNS monitoring solution, and everybody likes open source. So that's why we're here. So why is it called DNS Miner? There's a lot of questions in the beginning of the presentation, and that's sort of on purpose. We put together a lot of the white paper and everything that we submitted for this, but it still answered a lot of questions. We still had a lot of stuff to begin with, so there's a lot of questions to answer before we get going. So why DNS Miner? Well, a miner typically would have to sift through a ton of trash rock in order to find a diamond. DNS records are no exception. There's tons of them. Most of them are benign, but there's one or two in your environment that could lead to better investigation if you were to find it. In keeping with the theme, everything is actually named after various roles inside of a mine, and again, some of that will become very clear. So securing DNS, I hope everybody understands why it's important. But if not, that's fine too. We're here to learn, right? So the government cares an awful lot and reminded us that securing DNS on your outbound is a good idea, and created a report as such. So because we all know it doesn't necessarily mean management knows it, but you can come to them with this report, lends credibility to your cause, and gives you something to fall back on. DNS is also really good for covert channels. So we have some examples of how DNS can be used as a reverse shell for data exfiltration. And I won't spoil what that ended up doing. It was kind of neat, so we'll just leave it there. And everybody's willing to put a firewall anywhere. You tell your boss you need a firewall somewhere and he'll write you a check as long as nobody needs new printers that quarter. But given that situation, nobody's really paying attention to what the domain name traffic is doing, so it's often really overlooked. It's also really difficult. DNS, we all understand how it works, and we could all stand up a DNS server, but really securing it takes a lot of work, a lot of effort. There's some really good guides out there. We're not really going to dig into those now, but if you can't find them, let us know, and we'll send you the reports we used for this, and you're more than welcome to read through it. So securing DNS transactions, again, we're not really going to go too deep into this. This is all from a NIST report that we used to develop the presentation. If anybody really wants to read into it, I think it's 300 pages or some ridiculous amount, so if you're looking for something to do on the flight home, this will work out really well. Same deal here, securing your DNS query and response. A lot of this is pertaining to DNSSEC. DNS Miner doesn't use DNSSEC, doesn't implement DNSSEC in any way, but it won't break it. So if you have to use it in your environment, you want to have this extra layer, be my guest. So how we responded, this is a really good question as to, okay, so here you have all these security things you have to do. How is this tool set designed to handle that? Well, we have ACLs which block the traffic from unknown hosts. Everything is on the white list or it doesn't get through. Everything that has to be authorized. Each client, we have different users that were using this. They're on a view base, so you can actually see what each single client is doing, but it can't talk across each client environment, so it works out pretty well that way. And again, DNSSEC is up to the rest of the world, but this won't break it. So I think some people in here may have responded to this survey. We won't go over the stats. We have a lot to cover. We just kept writing, and then we realized we only have 45 minutes, so we should trim some of this down. So at the beginning here, you see the 45% cited lack of visibility into the environment. I think we can all agree with that. You know, roughly half of us seem like being unable to see into our own environment is a really big risk. But the bottom stat is especially scary. 1 in 4 feel that because they detected it, they found that it led to a breach. And good for them, but what about the other 3 of the 4 who didn't find a breach? Was that because no breach occurred or because they just couldn't see? I think we all know which answer that might end up being. All right. I like BTO. I think they're a group of pleasant old men. I wrote this slide and I'm sort of proud of it. So taking care of business. So let's suppose a scenario, and I think we've all run into this. I especially have run into this. You get a list of 20 questionable IP addresses from a firewall admin, and you have an overzealous director who says you have to have this sorted out by the end of the day. I mean, I'm by no means incredibly senior, but I do know a thing or two. And when it came to investigating this, you'd have to mine different intelligence feeds, whatever you could find. Some would say it's good, some would say it's bad, some have no opinion. So as you start to get down the rabbit hole, it gets increasingly more difficult to develop a yes, no, maybe so kind of answer. So if we suppose that it takes you roughly 30 minutes for each IP address, which is probably a median rate. Some might be really quick, some might take longer, so let's just assume 30 minutes. All of a sudden, those 20 IPs become 10 hours of work. I guess we're working overtime. So let's try that again. With DNS Miner, and we've tested this, I personally tested this, your list of 20 IPs, all of a sudden you plug it into your DNS Miner, and the console will show you everything you need to know about the answer. It'll give you the IP address, when it was requested, the name server that handed it out, a whole bunch of other really good information that we'll get into a little bit later. And now it takes you 5 minutes per IP address as opposed to 30 minutes, because you can immediately weed out which ones you don't care about by putting in the IPs and going, yeah, that belongs to Google, I don't care, I'm going to move on. So it actually makes your incident response time a lot easier, and all of a sudden your 10 hours became 90 minutes. So finish your spreadsheet and start your weekend early. All right, so we're preaching to the converted on a lot of this. I think some people are really in agreement with that. So let's go over what it means to the business. So the way we got to distributed was we had multiple cloud providers in the event that there's a geographical disruptance, or what really happened is credit card got owned and the auto pay didn't get updated, and all of a sudden the server stopped responding, which became kind of frightening. However, because of the way it's set up, fault tolerant wise, there was no outage. It was just an inconvenience. So if we look at the rates, I won't go into each one here, but the rates boil down to about $65 a month. Now that's, again, Canadian, so 40 bucks American, give or take. So that's, so that's not a bad deal, right? But what does that all mean? Let's put it in some context. So the business is going to come to you, the accountant's going to look at you and say, okay, but what is this actually going to cost, right? So for supposing that one of these incidents happens a month, and maybe it's an operational task and an awful lot of people would have that, in an environment without DNS Miner, there's zero additional compute cost, meaning it doesn't cost you anything extra. Whatever you have in there or don't have in there doesn't cost you any more or less, so that's at a zero. But you still have that 10 hours of work every month. And if we suppose an average loaded rate of $65 an hour, that's a $650 monthly incident that you have to pay for. Maybe if you're a one-man security guy, you have to fit that into your firewall admin, patching, user awareness, whatever else it might be. So it gets difficult. And the worst part is, at the end of the day, you only have a medium understanding of what you've seen, because you've had to mine some of these sources that may say it's good, may say it's bad. It just depends, right? So your level of confidence isn't as high as if you were using DNS Miner. So let's segue to what happens if you do use it. So it's $65 a month Canadian. We suppose the same loaded rate, but it ends up being roughly $160, $165 a month, give or take, to have this as an operational task. And your degree of confidence in your response is now a lot higher. So we broke it out over the course of a year, and I think it saves the business roughly $5,000 if you're working this every month. That's not huge, but again, if you're a small shop or you have a bean counter that's especially interested in the bottom line, this actually is fairly attractive. So what else does it do? Well, it's a DNS sinkhole, leverages passive DNS, historical log analysis using open source threat intelligence feeds, which we'll get into a little later, and it actually enforces rule sets. So response policy zone means that users who connect intentionally or unintentionally, if that domain is on the naughty list, they get redirected. And we also offer big data analytics, big data being a good word, and some customizable reporting. So we have some pre-canned reporting, but you as the admin can build your own however you like it. It's entirely up to you. So here's how it works from the end user. Can I get this from here? Okay. I don't have to go in front, no feedback for me. So you have your user connected behind your corporate firewall. This can be iPads, desktops, workstations, whatever the situation might be. Makes a query for a malicious domain. Now this may be inadvertent. Maybe they have a piece of malware that's phoning out. Maybe they don't know that this link they've been convinced to click on is bad. We can't always assume that they're being foolish. So in this scenario, they would make the request. Request gets answered and some magic happens in the cloud. We'll go over the magic a little later. This is just from their point of view. And instead of being directed to the malicious domain, they get redirected to an internal web server that says, you may have come across this domain. This is a bad thing. Please tell somebody.
All right, thanks, AJ. That's great. So we're going to start diving into this from the perspective of the end user and the incident responder. So we picked on this, some people are going to call this blacklisting or black holing DNS RBL. The terminology isn't as important as the fact that what we're trying to do is disrupt the attack chain, kill chain, whatever your preference is. And we picked on DNS because hardly anybody's looking at it. And number two, it provides that context that you don't get from just a straight IP address. And the main reason for that is a lot of the campaigns we're seeing, the attackers, bad guys, whatever you want to call them, are using the same hosted infrastructure as your mom's flower shop and indie rock bands. And I'm a big fan of indie rock bands, and every mom should have a chance to run her own flower shop. So you don't want to blacklist those, right? So what we did was we built we felt this need for redirection. And the function of the Canary server is to actually direct the user to a safe place that we can control, because we want to have some metrics on what happened. And there's a lot of sinkhole guidance out there you're going to find on the internet that says just send them to localhost or just drop the traffic and life will be good. And you've stopped the attack, but we think you need more control than that. So here's a quick sample look at a piece of the file infrastructure. And anything that's going to 507.ru, domain 1, domain 2.507.ru, we're going to redirect it back to a server that we can control. Now, we say it's an app. It's got a pretty low footprint. It's a couple of web pages, and they're written in ASP or PHP. It's all server-side, but the samples in the Git repo also include a style sheet. And a style sheet, you say, why would you need a style sheet? Well, AJ had mentioned user awareness. So it's really important that when the user gets that link, they actually feel like this is legit. And so if you're not a real web developer, and you can tell by the HTML there that I'm not, any reasonable sysadmin could take the style sheet, tweak it to have it the same look and feel as whatever your company internal documentation looks like. And the part that I really think is useful is, as an IR person, with this I'm getting things like the user agent string for their browser, because depending on the attack, hey, I've seen it where I'm only looking for Firefox browsers or something like that. So that's a little piece of intel you grab about your attacker's tactics. You get the fully qualified domain name that they were looking for. You're going to get things like the query string that they requested as part of that, if it's there. And most importantly, you get the inside IP address of the user or users that clicked, and you do that all without an agent. And that was the number one thing. We wanted to make sure there was no agent. Now, I'm pretty sure there are people around this, maybe in this room, that could do way better at sniffing out information on a user's browser session and add even more context to that. But however you go about it, we need to get that intel back on what that user did. And one more thing that I just forgot about. You see those dashed lines there? When all we got to do, get that user to swipe that, cut and paste it into an email, and there's your reporting. Now, if they happen not to report, because users never like to say I did something bad, there's also a log on the Canary server that contains all the same information. So I'm not sure how many people saw Ed's talk that just went in front of us. If you didn't, you got to go check out the video, because it's good. He's talking about open source threat intelligence, and I think that it's a super valuable asset, but we also got to watch the return on investment, because IPs on their own are not really what I would call something worth blowing your budget on. So big shout out to the guys at Critical Stack and their free threat intel mart that plugs into Bro. That's a very cool idea. This one here, currently what we're doing is downloading about a half a dozen lists over HTTP. We're normalizing that data because every single list looks different. We have to dedupe and get rid of that, and then we got to munch all that stuff together in a form that the DNS nodes can actually consume it. This all goes on automatically once a day. And the nice thing about that is that it's going to get fixed, because I wrote it last summer. It's all in Bash, and the error handling is currently like old Microsoft: on error, resume next, just keep on going, ignore it. But, hey, this threat feed hasn't responded for a week, it was a freebie, maybe you want to take that off the list, right? Or, hey, we're paying for that one, so we should probably go give them a call, and hey, your API key expired, who knew? Now, the problem with lists that I've found is that everybody really wants to do the best job they can, but most of us are volunteers and it's a best effort thing. And I know from personal experience it's easier to get on some of those lists than off them. So if you find that you have a business partner or somebody who's on one of those lists, you definitely don't want to be dropping all the traffic to them. So there's a custom whitelist for each organization. And before the daily list is updated, the whitelist wins. There you go. That's what I was trying to say. Now, in Ed's talk as well, he had a honeypot and somebody was poking away a little and his malware drop zone came up. So maybe it's just a little one small guy who's not on anybody's list. You can add that that domain to this custom blacklist, and now you're protected even before it gets out to the regular population. So pretty flexible that way. And again, because you're updating this on the master bind zone, everything just replicates out to the recursive nodes without you having to do anything. So, it may not be 35 seconds, but it's going to be less than 15 minutes before you're covered from front to back, and you had to go to one place to cover it off. So I think that's pretty useful. All right, over to you for some big data stuff.
Big data. I like that word. I never really understood what it was until I was in a database class. But it's good to sell. So historical log analysis, all of these threat indicators, all this threat intelligence is a lagging indicator. So it doesn't really matter when you purchased the list or when you acquired the list, unless people are actively going to that domain at the time the list is implemented, or the domain is even still up. Chances are the campaign might be over, it's winding down, somebody else got busted and it's been torn down since then. You want the ability to look back in time. So that's what we do. Historical log analysis allows the admins to go back and query all of the domains that have been accessed for the last 30 days using an updated list. So maybe at the time a specific domain wasn't malicious because it wasn't big enough to get noticed, and then it wound up getting on somebody's list, somebody's radar, and now it is malicious, but it's too late. The damage is already done. Somebody in your environment had accessed this at some point. Well, now you can tell for sure. So the completion backwards principle is what this is called. And this essentially goes through and looks at all the domain traffic that had happened. And it strips out all the hosts and everything like that as part of the deduplication. It just does the top level domain. So if somebody accessed x.google, y.google, z.google, it doesn't matter. It strips it all out and says 3 requests were made to a Google domain. So it helps in your incident response and triage process to determine just how many times a specific domain at the top level was accessed. The 30-day window, this is a neat stat. Ed Skudis mentioned that we should grade our blue teams based on how well they handle their metrics and continue to improve. So according to the Verizon data breach report, the median time is 200 days to detect a breach. But because we have a 30-day window, you can now scale that way down. So it ends up looking pretty decent. And it provides good log forensic. Lots of artifacts there, so if you have to take this case a little bit further, perhaps to the local law authorities or whatever the situation might be, you actually have some artifacts to draw from. So as we can see here, this is a bit of an eye chart, so I apologize. We have some domains that have been accessed. Now, some of these were not malicious or deemed not malicious, and some of them were deemed questionable. However, if you look, the Melbourne IT hotkeysparking.com wasn't necessarily seen as a bad domain. And then this Furry Connections, we're not judging, it's just there, was also handed out from the same Melbourne IT. So you look at this and go, well, why do these two domains, why is there this correlation between these two domains? One of them was flagged, one of them wasn't, and it was handed out from the same name server. So it might be worth some investigation. So now you have a timeline that you can use from your reporting to go back into your portal, populate your timeline searches, and then dig in to see how many people had actually access this domain at any point in time. So we see here with looking at those domains, in that time frame, it was only accessed a couple times, not really a whole lot on one side or the other. So you can now turn around and make the assumption, perhaps, if you so choose to do so, that a user probably fat-fingered something, they accidentally clicked on a link that they thought was valid, but it didn't actually go anywhere in a malicious sense. And because there was no further traffic, or it was only coming from one or two hosts, it's probably not a huge deal. Or maybe you're looking for more billable hours, and this is a good way to kind of chase down some of that. It's entirely up to you at that point. So passive DNS, in Ed's talk just before this one, he brought up a really good question about threat intelligence. He says you should always ask your vendor, why is this a threat to me? Passive DNS really helps to answer that question because this already went through your environment. Passive DNS is backwards looking. So if you're finding these malicious domains in your portal, the answers have already come out of your environment. So this has already hit you. It's now a threat to you at any point. So the reason why passive DNS is useful is preserving your operational security. If you have an attacker that's targeting you, they may be watching their logs for any hits from your domain to see if their attack or their campaign has been successful, and they can start to launch into the next one. Because you're just looking at your own environment, nobody is the wiser as to who connected to where, and you're still getting all the full information at the time. Conversely, if the domain has been torn down, the information's been changed, or there just isn't really a lot of other information out there, you can actually still look at the answer itself. And the really nice thing about this, because it's built on NoSQL, it allows a lot of free-form data. So if for some reason the parser stripped out some specific domains, but you know they're in there, you can actually go right to the database layer and just query it directly and see all of the information that came with it. So you're not dropping any traffic, it's just storing and making itself accessible later on. Okay, this is a really difficult topic, so I'll pass it to the smart guy.
That's quite kind of you. Smart, I don't know. I'm standing on the shoulders of smart people, the guys that run ISC2, the guys that gave us DHCP and Bind, people like Paul Vixie who helped spearhead this particular initiative. So all we did was figure it out and make it work. We did not invent RPZ, but it rocks. And the reason why is because DNS clients will believe anything they are told by their name server. And sometime around bind 9.8 midstream, this response zone policy thing came into being. And it's great because now we can lie to the endpoint. But it's good for them, so it's all right. It's just they need to be told something a little different. So like I said, the documentation is pretty sparse. There's not a ton. I mean, you Google how to build a bind name server, you know, there's a ton. RPZ, a lot less. And it's somewhat obscure. But it's pretty simple when you break it down. There's two things that it does. It's got the ability to trigger on the content of a query and on the answer to a query. And then based on those triggers, you can take a bunch of different activity or actions. You can just log it and let it go. You can drop it like a rock and don't tell anybody. Or in our case, we're actually redirecting it to something that we can control. So, you know, it seems kind of wasteful to just drop it if we can go through it and get some detail for further analysis. So because it's still a zone file at its core, we can leverage all the stuff that you get for free, again, from those smart guys at ISC. So we get zone transfers, we get the ability to wrap ACLs around it and tie them to specific IPs and ports, and we can even sign that transfer with a cryptographic hash. So pretty confident that you're getting that notification from the genuine master server, not a bad one. So that was part of this concern because it's really good. It's really fast. It'll redirect you to somebody else right away. So if the bad guy gets a hold of your list, well, thank you for playing along. You just sped up the attack. So this list integrity becomes a very important thing. There are a few commercial services out there that offer this stuff in these threat intel feeds in RPZ format. When I looked into it, it looked like it was geared more towards large providers and not so much small one-man, two-man, women armies, you know, like it's great to see some women in these talks, isn't it? I think this is fantastic that we see women in security. It's about time. We need all points of view on this. But if you're curious about the commercial stuff, was that DNS, not DNZ, DNSRPZinfo.com, and you can follow that one up. So when you look at his RPZ zone file, it's pretty conventional. He did this. This was pretty cool. You can shoot at the back of the screen. All right. Who knew? Science, eh? Science rocks. Okay. So that stuff at the top, if you've ever worked with DNS, that's your standard time to live, origin statements, and all the rest. But unlike the conventional guidance you're going to find on how to build a sinkhole, when you normally build it and claim authority in that zone file statement that bind reads on master, you have to declare every single authoritative zone, even if they're all pointing to the same darn go nowhere file. Well, that's great if you got 24. But try doing it with 13,000. Okay, 5 minutes later, bind finally reloads. Use an RPZ, it takes a few seconds to reload. And they've got another technology that we didn't even go down because it was good enough. It's called mapping. And they're saying that'll scale out into the millions. So you could probably extend this to do funky things like not just bad domains, but how about websites that I don't want people going? There's open source feeds of, you know, adult content and stuff that you can throw into your squid boxes. You could probably suck that down and fire it in here and maybe even send them to a second canary server that says, yeah, you shouldn't be here, but we're not going to come visit your desk. Get back to work, yeah. Like, who serves porn at work? I don't know, but they do. I've never either, but walked a few people out. Okay, so regardless of how your endpoint gets directed there, the IR team needs the information about that event to divine the severity of the event. Again, back to these elusive security metrics, but simpling it down, 2 users making 100 connections to bad places is vastly different, in my opinion, than 100 users making 2 connections to bad places. Because, well, that's my opinion. I'm pretty sure I saw some heads nodding, so I think we're there. But if you've got a tool that simply counts connections to bad place, oh, I've got 200, the sky's falling, let's get a Sev1 ticket going. You could be spinning a lot of cycles chasing down 2 people with active machines. And conversely, you could say it's only 200, we set our threshold to 2,000. Yeah, but the bad guys only go out twice a day and you have 100 people infected. Yeah, but it was under the metrics, so we're good. It's a P4. You know, we need that extra insight. Like Ed had mentioned, you got to do the analysis on the numbers. So this gives you that canary server, like I said, captures everything we saw in the web page. So even if the users didn't report, you go back. So one of the things that I like about this was with the Elasticsearch and the Logstash underpinnings, we built a parser to take this flat, ugly RPZ log that comes out of bind. Hey, they made us the tool. They didn't say it was going to be pretty. So the log is not the friendliest. And we were able to build a custom parser that reads this stuff and breaks out the various elements that we found interesting, and you can convert them into visualization. So again, the concept of using a bind view says, I can say, if you come from that IP address, you're coming from Michigan. And if you're coming from that IP address, you're coming from the Ontario office. And that address, that's the Denver office. Lots of people are small shops and you're responsible for 3 or 4 locations. Well, this allows you to say where it happened. So that middle blue thing in the donut there, the middle blue line says this actually only happened in 1 spot. So good, I'm not looking at the other 2, it only happened in Denver. Those Denver people, we're just not getting through to them. I don't know. Denver's like Calgary, actually. Yep. Just as snowy, just as dry. But then you look at the next ring around there where we've got all these different little slices. That shows that they were asking for individual domains, not 100 requests to the same domain, but a request to 100 different domains. So now we're probably dealing with something that's using some kind of domain generating algorithm or something like that. Now, the charts and graphs are good. They keep the management happy, and oh, you must be working hard. Look at all those numbers. But when you're the analyst, you're going to have to drill down to single events. And if you've ever worked with Splunk or ArcSight or a lot of these other tools, this is, you know, Kibana's just like that. You know, they even make, it must be mandatory that those bars in the middle are green or blue, because that seems to be the only colors they come in. And again, we built parsers out because Kibana does pretty good with text and stuff like that, but log data, nah, your mileage may vary. And we were finding it was doing weird things and truncating stuff and going, our reports are looking weird. So we actually had to build out custom parsers. But we've done it for passive DNS, forward DNS, and RPZ. And the nice thing is that all these little elements like the IP addresses of the authoritative name servers and the actual full domain name and the answers and all that, they're broken out. The type of DNS query, was it a text, was it a CNAME? Those can all be used as field sets to break out a view. So instead of looking at a raw log, or worse, logging onto 3 or 4 name servers and catting it all out and piping it to awk and sed, I mean, I think that's cool, but it really is tough to take all of that and now you got to suck it all back. This is all in one view and it's fast. And again, we just don't have time to do a lot of this stuff. So we can come to that conclusion real fast that it's not a big deal or, oh my goodness, that's where we've got that. So big data, I think we've covered off a fair bit there. So we'll go through that and just jump into the reporting.
So the reporting side of things, again, for the console, we're using Kibana with Elasticsearch and Logstash to go ahead and parse it. But at some point, all of your data ends up in an Excel spreadsheet. I think that's just sort of par for the course. So it's really important to be able to dump that data nice and conveniently. So that's what we did. Again, can you tell we're not web developers? This is sort of the best we could do. If anybody's willing to take a crack at making it look nicer or have full features, come see us. We don't pay. See if anyone wants exposure. So in this scenario, you can see a daily report gets dumped, and these are all of the domains that had been accessed, their counts, everything like that. And you can actually just go ahead and download that. Dumps it right to a CSV file, and it actually looks pretty easy to work with. So we can see the top 2, Google and Facebook. We already know that we don't really care too much about those, maybe from a productivity standpoint, but that's not what we're here to do. The column A determines how many times those domains were accessed, and then column C will tell you the type of requests that were made, and then column D will tell you how many times it's been requested in the last 10 days, and E will finally tell you when the first request started showing up. So the first 2 we're not particularly interested in, so we can likely ignore that, but this B42.ca, well, that's kind of curious because we're seeing an awful lot of weird DNS traffic, and it happened a whole lot, and it's only really been accessed a very small amount in the last 10 days. So can anybody take a guess at why that might be a bad thing? Yeah, it's early Sunday morning. I get it. It's essentially a covert channel is what was created here. Now, this is all for the purposes of testing. This was done on purpose, but we start to see a lot of this weird DNS traffic going out of our environment, and at that point, some red flags should be going up and some investigation should take place.
Yeah, so it seems like Murphy's Law. When you're in the middle of an incident, that's when you find out that you don't have all the events coming from the event source, or more likely, yeah, that hasn't worked for about 6 weeks. So you got no logs at all. Yeah. So I think when we commission stuff, sometimes we actually take that final step and actually validate that it works as intended. You know, run Nmap and hey, my IDS went offset, I did a port scan, good enough. Next. But we never go back and check. So, you know, they have fire drills in large buildings a couple of times a year to make sure that, hey, the alarms went off and people knew that that's where the exit was and stuff. We should be doing the same sort of thing. So came up with this concept of first I needed to replicate a covert channel. So I installed Ron Bose from Skull Security's DNS Cat 2 and just turned it loose. But I also wanted to make sure my RPZ stuff was working right with a domain generating algorithm. So I wrote one. It's kind of cool. Then you go, hey, we could exfil data with this too. Hey, we could do, and you start to think and get creative about stuff that you could do with simulating traffic that simulates what an attacker's doing. So you're kind of red teaming your own stuff with your own data, and now you can start writing reports and maybe even triggering alarms based on the fact, yeah, if that ever happens, somebody's up to this and we want to know about that. Well, since you wrote it in a script, you can run that again next quarter and make sure the alarm still goes off. And if you're really nasty, you could actually test your blue team and see if they actually respond to the alarm going off. But since it's probably the one-man or two-person army, there's not a lot of sport in that. Hey, yeah, that's me. It's not quite the same amount of fun. So how this works underneath is, as I said, the magic happens in the cloud. So your boss will believe that. That's all great. This was supposed to be a simple little DNS sinkhole, and I think we got 7 or 8 boxes going here, so it got a little out of hand. But the point of building this out in a very big distributed manner was to make sure that it could, because more than a few times I've seen apps that work okay on one box, but the minute you start to spread things out, they start to fail, right? So it's all in the white paper on which boxes do what, but essentially we're getting passive DNS out of the forwarders. You've got forward DNS coming out of these recursive nodes, and as AJ mentioned, because we've got so many, almost nothing will break. But the easy part that we don't really get to here is all you got to do to turn this on in your environment is go to your Active Directory domain controllers and say, by the way, instead of forwarding all your DNS requests out to our local ISP, which you've been doing for years, send them to these boxes that I control. If it doesn't work, send it back to the old way and nobody's the wiser. If you want to try it with one AD because you've got 6 and you just want to do a soft launch and see what you get, there you go. And you can keep an eye and watch this thing scale up, scale backwards. It's all built on cloud, so, you know, you don't need to get the network guys or anything involved. And cloud's kind of expensive, but the one thing that is cool is you get your internet for free off of those guys. So you've got public IP addresses and lots of bandwidth and no groveling with the network team. So it's actually kind of useful. So if you want to build your own, there's a lot to this, but it was difficult to pull this off. So as I was going through this and going, this is awkward. So what we did was we built out a Git repo that has all of the different components built out so that you run menus and scripts and things like that, and they'll build out the various elements. And I'm not sure we're actually going to get to the demo, but it's pretty straight up. You log in and it'll draw down the various tools in a folder. You can see everything that's there built out. We probably got about 25, 30 different programs and scripts. And we're working on a menu. I've got a buddy back home who's exceptionally good at finding the one input value that you never would have thought anybody put in, and your stuff will blow up. So I'm going to let him blow it all up again from scratch, and then we'll go forward and put together the full-blown cookbook. So there we are.
So just so everybody knows, we will make this presentation available, including the demo on how the menu-driven programming works. It will be uploaded to our marketing webpage after this. So we just didn't want to tip our hand. You know, we like surprises too. So the design summary, essentially what this is, designed to bridge gaps between your identification and your containment strategies during incident response. Whichever methodology you subscribe to, there's always those 2 first steps. The idea here is it's designed to sort of close that and make things a little bit easier for you. Because it's leveraging open source and cloud-based infrastructure, you can do it however you want. If you prefer to use a different brand of NoSQL, fill your boots. If you aren't super fond of Nginx, build it on LAMP. If you have a lot of Microsoft licenses, do whatever you'd like to do with that. So it's really flexible in that sense, and we're providing you the code and the ability to start building this on your own. And we'll make it available if people want to connect to our version of it. That's also an option. So we're pretty flexible. I feel like in another life, if I was lazier and more intelligent, Wally would have been my spirit animal. I really identify with him in a sense that if I really didn't care about my job and whatever it was I would do it, I would probably really embody everything he's doing. We get it. We're not cloud champions, okay? Not everybody's in favor of putting all of their information in a data center they don't control. It makes perfect sense. Despite all that, we're still not cloud champions. We get it. The beauty of this is you can stand it up inside your own infrastructure. You can put it all on a single physical server if you really want to. But the idea was we wanted to make it distributed, highly available, and easier to access without costing a lot of money or resources. So that's why the cloud came around. But if you are really adverse to it, stand up your recursive nodes in a DMZ, put your Elk stack somewhere in your environment, and have everything phoning home through firewalls and everything you control. It's up to you. Whenever I leave the house, I know I lock the door, but I always am at work going, oh, I hope I didn't forget to lock the door. And that's why I work from home now, so that I don't have to worry about that. But throughout the whole software development lifecycle, security was really paramount. We made sure that whatever we were developing and releasing into the project was secured. So it goes to show you that you can develop anything in a secured manner. Full disclosure, it did take longer because we had to make sure things were secure first before uploading and testing, and oh, this won't connect because of this weird... We had those same issues. However, it's a lot easier to do it and then implement it right away, as opposed to build it, go, oh, we didn't think about security, have to go right back to square one securing all this and rejigging all of your software so that it works. So in the end, it does end up saving time. Doesn't mean it isn't frustrating. So how do we keep consistency? Well, like we said, we have a GitHub. You can run up and do a git clone, grab the scripts, and spin up a new server before lunchtime. And because it's all scripted and semi-automated, you're getting the same development, you're getting the same builds every time. So as we make changes, they get uploaded to the GitHub, and you can go ahead and update from there. So monitoring, we'll just go over really quick. We did think about monitoring infrastructure and application layer. We use Nagios because we're cheap, and it does Linux monitoring quite well. These are all Linux-based environments, so we wanted to make sure that was well thought out. The services monitoring, we're not going to go over this. Essentially, each server has processes that have to be monitored. Again, we'll make this available, so if you are standing up your own, here's some of the stuff you have to pay attention to. So infrastructure and procurement. We have questions of why did you pick this technology and not that technology? Why did you go with Elasticsearch instead of something else? Well, we pick technologies that are open source, that have a good community, and have a good reputation. So if it seems like a technology doesn't really have a lot of community or backing, putting your eggs in that basket might be dangerous if all of a sudden nobody decides to know how to use it and you're all of a sudden the only guy who can maintain this thing. Great job security, but it also means you can't move anywhere. So we wanted to keep things really open source with a lot of wide community support. So features we plan to add, again, because we had to accelerate some of the development, some things had to get dropped off. So system and application monitoring aren't quite stood up yet, so we're working on that. Web-based menu-driven, so instead of going into the command line and running your stuff, yeah, we all like the command line, but not everybody likes it. You can actually go right to a web page that we're planning to build and hopefully make it look better than we normally do. And OSEC will be used for file integrity monitoring, so that becomes pretty important to maintain your file integrity, your list integrity, to know that stuff isn't getting dropped from your blacklist in the event that those servers get owned. And in-depth documentation. Again, some things had to get dropped. Documentation's always the first one to go, so we have to really improve that, because what we have now isn't really anything to write home about. And we do have a public-facing wiki on the way, which will help with the contributions. So that'll be really useful for other people who want to assist. Again, it's open source. We're hoping people can help out. So we're almost done here. So the call to action, we hope that MSPs and ISPs can implement this as a service without adding extra cost to the consumers. We're two guys in a shack, and we did this. There's no reason why major telcos couldn't offer this as a DNS service line item. And frankly, it could be for free because it doesn't cost anything to build. The maintenance is very cheap, really nice and easy. We need people for data. Now, obviously, you can't just connect to it, but if you're interested in partaking in the project in any way, we'll have our contact information. Do reach out. We are interested in scaling up and seeing if this really goes to 11. We envision it does, but we're not quite sure. And frankly, if anybody has contributions, things they would like to add, even just comments, all that stuff is really useful. We're really interested in that. So, end notes. You can develop securely. Anybody who says you can't, I think, is lying to you. And this is proof positive because we develop securely. Again, frustrating, but still doable. Your open source mileage may vary, so just be aware of that. We'll obviously try and help you any way we can. If you're standing this up on your own, you're running into some issues, don't hesitate to reach out, and we'll be more than willing to help out. So some special thanks, Darlene for continued love and support, the curly-haired menace I call sweetheart, Marcia, for letting me slack on the housework, and a lot of other people in our lives that really helped get this project going. Some of the users we had who were helping out with the alpha testing. DerbyCon for accepting our talk and accelerating our timelines faster than we could have thought. Thank you for everybody for coming. This was more than I think any of us expected. And really all the great researchers who helped develop these solutions so that we could glue them together and turn it into a cohesive unit. Any questions? Yeah, the guy next to the clown. What is that? That's awful. Oh, that's frightening. So yeah, go ahead, sorry. Yeah, exactly right. Yes, yeah, here.
Sorry. So yeah, AD obviously is everywhere, and if you've ever looked at a Windows Active Directory log, it's huge and full of all kinds of stuff about the local directory. We wanted to slice that 80-20 to get in the middle of that attack chain. Most of your attackers hopefully don't have an Active Directory DNS record. They're on the outside, so this really just grabs the recursive stuff that leaves your environment, and we hook it there and push that back in. That's how we get around it, and we use the source address of where that query came from to push you back to the designated canary server. Anything else? Okay, well, thank you guys so much for coming out. And we even got a new Twitter handle. We'll do our first tweet here in a few minutes.